The way I have designed this is there is something for everyone. If you're new to Spark, there is something for you. If you have been building Spark streaming applications for years, there's still in-depth content for you. For the last 4 years at Databricks, I have been taking streaming workloads to production almost every week. Decisions will be made in real time, regardless of whether real time analytics is available or not. You don't need to start learning a brand new paradigm. The same APIs work, the same engine works. Checkpointing says you don't worry about what's net new. I'll identify what's net new and only process that. And after all the data is exhausted, it will shut down the cluster automatically for you. So that's the benefit of trigger available now. As long as max offsets behind latest is dropping for your running streaming job, it means your processing rate is automatically greater than input rate. That's why this is happening. And you are not lagging behind. One should always be on the latest technology stack or at least on the popular technology stack because it helps in career growth. Thanks for joining in. If you don't know me, my name is Jitesh. We are going to have a masterclass on Spark Streaming today. Let's get on to the agenda. We're going to do a short intro on Spark Streaming. Then we are going to spend a majority of the time doing a live demo. The way I have designed this is there is something for everyone. If you're new to Spark, there is something for you. If you have been building Spark streaming applications for years, there's still some in-depth content for you. I've tailored the content for both the audience, someone who is just new, just getting started with Spark streaming, learning about it. For folks who have been working with Spark streaming, we are also doing a deep dive for them. So that way both the audience get addressed. And then we'll talk about keeping in touch, how you can connect with me. And we are going to, in the end, talk about the next session, which is planned maybe 2 weeks from now. And then we'll have a dedicated Q&A. And in that Q&A, you can ask any questions about this topic. If you have questions about your own problems in data engineering or streaming, we can discuss those as well. I write under the pen name Canadian Data Guy for the last 2 years. I've been creating technical content. Most of them was blogs. And now I'm getting into YouTube and doing live videos because I honestly don't like reading a lot. I learn a lot watching YouTube myself. So that's why I'm addressing the people who want to watch technical content but prefer videos over written material. I have 12 years experience in data engineering and data architecture. I spent 6 years at Amazon and AWS and 4 years at Databricks. For the last 4 years at Databricks, I have been taking streaming workloads to production almost every week. So lots of in-depth experience on streaming. I'm trying to give you the content which I did not get when I was starting my streaming journey. Hopefully, this resonates with you folks. Disclaimer, anything you see on the slides or in the demos today is coming from my personal knowledge, experience, and opinion. It does not reflect any endorsement from either of the companies I work for or have worked for. So, why real time or why streaming? This is a quote from Gartner, which I really like. Decisions will be made in real time, regardless of whether real time analytics is available or not. I think that's just a very good summary. Like, world works in real time. If you can work at the same speed, good on you. If you cannot, you're going to just lose out. I think that's the crux of why you should be doing it. So, why are folks not able to do streaming? The biggest reason is that it is complex. There is a small learning curve involved. And historically, people used to have separate systems. Like 4 years ago, you would have a real time system, which would be Elasticsearch powered. It could be Spark powered for the batch. And then there were two separate systems, which was one which was doing just pure real time stuff, and another system which was just doing pure batch stuff. And then what you do is create a layer on top, which would logically represent the combined data set. I mean, the real time data set, which was trying to operate near real time, and the batch data set. So we had this paradigm where the technology was too complex a couple of years ago. Now, either people are in that technology stack or they are not aware how the systems have evolved. or we are aware, we just have not got time to look into it. Okay, let's go on. So this is another slide which I like, which is about, hey, for different latency, what you can do, right? So if you are working in a daily, weekly, monthly fashion, you're probably into forecasting or doing basic reporting and basic analytics. If you are at an hourly cadence where you process data every hour, say you are Amazon and trying to figure out how many orders came in the last hour and then make predictions on how many employees to bring in to package the stuff, or you are Instacart, which is you have a bunch of deliveries scheduled and now you're trying to respond to it, right? So when we come into the hourly category or the minute category, at least I would say you're approaching the near real time paradigm. And then there is true real time, which is, like YouTube Live is an example where I go live, you folks get a notification, which probably happens in milliseconds, or you order something on Amazon's webpage, which is you're responding to it in real time. So this, when you are in the millisecond range, is called true real time. If you are in the seconds range, it's called near real time. And minutes to hoursly, you can say, is your traditional batch. So where does Spark currently operate? Spark actually supports both. Spark supports true real time. There is a Spark streaming has a specific mode for that. It's new. It's still experimental. But if you're thinking like seconds, like 1 second, 2 second, 3 seconds, or say between 1 to 10 seconds, Spark streaming has a mode called micro batch mode, which is a default mode that can easily operate in the near real time mode. So just for clarification, if you're trying to design something for less than 800 milliseconds, right now the best technology is Flink. And if you get above 800 millisecond benchmark, Spark streaming just becomes your friend because it's so much easier than Flink. How should you decide what should be your latency? You ask the business, what does this business need? Right? Not everything has to be real time. If you do things in bulk, you can optimize for cost because you'll get better CPU utilization. The more you try to do it real time, you get into the territory of things getting more expensive because you're trying to get greedy. You're trying to minimize latency, means you'll have to give more CPU power. That being said, if you're in the minute range, you have a very good balance, right? I think you can achieve both low latency and low cost. When you're ultra optimizing for latency, say 5 seconds, 3 seconds, at that point, you probably are using more compute than you need to. So you ask your business, what's the use case? Say you are Instacart and you need to get packages scheduled to be delivered. You need to understand, hey, what's the frequency on which we're going to get the order scheduled? Say business says every 1 hour, we want the orders to be scheduled. Then my thumb rule is divided by 3. So if someone says, I want data in 60 minutes, I divide it by 3. So my processing time becomes 20 minutes. The reason I do that is because in case I have a failure, or in case the cluster has a failure, whatever failure happens, then we have time to recover. That way we'll not miss our SLA of 1 hour, but still be able to achieve the output. Okay, why Spark structured streaming? The first point, honestly, is my favorite, which is you don't need to start learning a brand new paradigm. The same APIs work, the same engine works. This unified API layer is what I really enjoy about Spark streaming, such that I don't have to learn two frameworks at once. I can just enhance my understanding of Spark streaming and then I'm done. Other than that, obviously, fault tolerance and recovery is there. If a failure happens, that's automatically handled. Another thing which I like is you don't have to worry about duplicate processing of data. Checkpoint handles it. Let me give you an example. Say you're processing your advertising data, right? And let's take Amazon as an example. Say you're processing Amazon's ads data set. An ads data set from an industry perspective does not stabilize for like 3 days. Historically, what one could have done is if you understood that data did not stabilize or the whole data does not arrive till 3 days, every day you will process day minus one, day minus two, and day minus three because you could not identify which day is complete or not. So essentially, you're paying 3x the cost. Checkpointing takes it away from you. Checkpointing says, you don't worry about what's net new. I'll identify what's net new and only process that. That's where, by the way, how things become cheaper because you're only processing data, what needs to be processed. Performance throughput. So you can do 14 million events a second. I have personally done 5 million events a second. If you sum it up at a month level, it's close to a petabyte. So you can really scale this. This is a common misconception in the industry where when people think streaming, they think continuous. When I say streaming, you should understand that we are doing incremental processing of data. You should not think that this is continuous. Spark streaming is very good that you can choose if you want to be continuous, run all the time, or if you want to run every 15 minutes or once a week. You can still be streaming without being continuous. That's the flexibility which Spark streaming offers, and it's very commonly misunderstood. People streaming, they may think continuous is expensive, and thus they're like, oh, we don't want to do this. So, just for clarity, Spark streaming means incremental. So, top reasons to start streaming today. Apart from the fact that it's a hot area, most of the engineers are starting to do this. Databricks has a metric of 14 million jobs are scheduled every week which are streaming. It's a hot technology. And if you're trying to get better jobs, being on a newer technology stack helps you crack your job. Because if someone hires you, they know that you know the technology stack. Now you need to just learn the business. You'll be productive very soon. Whereas if you come from an older stack, you have to absolutely nail every part of the interview. One should always be on the latest technology stack or at least on a popular technology stack because it helps in career growth. It helps in cracking your next opportunity, even if you don't absolutely ace your interviews. Okay, top reasons to start streaming apart from career growth. One thing I told you, a life without input parameters. So we are saying, hey, let's process the data and let Spark worry about what is there to process. Like Spark, specifically Spark streaming will worry about what is there to process. I don't have to tell it which days data has arrived. So like in your traditional batch jobs, you specify input parameters, right? Like a date parameter or a country parameter. In streaming, you don't need to do that because streaming already takes care of that. The second point, which is you can decide to change your schedule anytime without making code changes or minimal code changes, I should say. So if you have a streaming job, which you today run once a day, and tomorrow you want to run it every 4 hours, you just have to change a line of code and you're going to start processing the data every 4 hours. So even if you are doing Spark batch jobs today, and your business does not have a reason to do streaming, I would still say get onto the streaming paradigm because when the business reaches a point where they're like, yeah, we want better SLAs on this, then it's a small code change for you. So you're going to upskill yourself because you learn a new stack, you learn about streaming. You'll still be able to meet your business needs. If the business says, hey, we want better SLA, then it's literally one line code change for you. The fourth point with my Amazon advertising example is it helps you drop cost. If you are in a batch system and your data does not stabilize or you have late arriving data, usually people keep reprocessing the older days. You'll be able to get away with it. And that's where the cost savings would come in, which is you are only going to process what needs to be processed. That's it. And that's where efficiency would come in. Top reasons not to do streaming. I'm a very transparent person and I spend half an hour at least twice thinking, why shouldn't one do this? And for the last 4 years, I've been working with so many clients trying to get them onto streaming. I couldn't think of many reasons apart from the learning curve. So, apart from the fact that you don't have the time to learn about checkpoints, you don't have the time to test your jobs, and maybe hard. This is a debatable thing which I'm going to say next. If a lot of complex aggregations, then maybe Spark streaming is not the right tool for you. But even that is debatable. Like I can give a counter argument right now to say why even for a complex aggregation use case, streaming is a better one. But these are the reasons you shouldn't do streaming, which is I'm saying kind of there is none. except that there is a small learning curve and a time to do some testing. So, how is the Spark job different from a Spark streaming job? So, Spark job essentially you can think as three components. There's the source, there's the transformations, joins, aggregations, and then there is a target. So, source, transform, and target. How is the Spark streaming job different? The Spark streaming job has just one additional concept of checkpointing. And then there is a caveat that not all sources have support for streaming. Example, if you're reading from Kafka, Kinesis, Event Hub, anything on S3, ADLS, Google Cloud Storage, all of those can be streamed. But if you have Postgres table as a source, that cannot be streamed. If you have a Snowflake table as a source, that cannot be streamed. So that's the limitation right now, that not all sources can be streaming, but between Kafka Kinesis and any file type on S3, you cover almost all use cases. Now we'll directly get into the demo. For beginners, we will show you the initial code such that you can copy the code, you can make it your own, and you can develop your first Spark streaming job today. And for people who have been building Spark streaming jobs, we are going to open a checkpoint and actually show you how checkpoint works, how Spark streaming works, how it's able to do fault recovery. So that's how we are going to split our time next. Before we go there, let me explain the Kafka architecture. Kafka is a distributed message engine. In this example, there are three nodes, node 1, node 2, node 3. Data is distributed across three different machines. And within those machines, there are different partitions, partition 1 to 6. Data is distributed across three machines across 6 partitions. Topic is analogous to a table in a database. And then within a partition, you'll have messages. Messages could be thought as rows. So in a database, you have row. In Kafka, you have a message. Every message has an offset number with it. Offset or sequence number, that's the terminology there. And every message can be uniquely identified by a combination of topic, partition number, and offset number. So that's always going to be unique. One misconception is offsets are not always contiguous, meaning it's not necessary that 3 needs to be followed by 4. You could have 0 followed by 2. Topic means a table in a database, message means a in Kafka. Partitions are just chunking of data, that's the methodology. And every row, aka message, can be identified by the combination of topic, partition number, offset number. Now we'll get into the demo and I'll show you how I'm doing this. By the way, if you don't have a Kafka cluster, you can sign up with Confluent Cloud. They give you $300 of credit. And the sample topic, creating some sample data for us to process. Right now, I'm not creating a lot of records, probably 2 messages a second, and I have like 19,000 messages outstanding. What I'm trying to say is you have only $300 of credit. If you're trying to do like a million records a second, I burned actually $1,000 with Confluent one time because I didn't keep a tab on the billing. So just keep a tab on billing if you get into the million records a second range. This demo will be done in less than $2, which they'll cover as part of credits. But just be aware. I tried to do it with AWS as well. It was very complicated to have a public Kafka cluster. If you're just trying to learn, go to Confluent, use their $300 of credit, get a cluster, get some data, and start doing your stuff. And that's going to be very cheap. So now I'm into Databricks. I don't know how many of you folks are using Databricks or not. For Databricks, you will get credits. You can sign up for Databricks and run this in your code, even if you don't get credits. I think this is $1 an hour kind of a thing. For clarification, I'm just using a single node machine with 4 cores. That's the cluster I'm using. I think it costs like 20 cents an hour or something. Now we'll get into the code. First things first, for any job, you need to have parameters. So I have created a scope. So I have to store Kafka's secret somewhere. To connect to your Kafka cluster, you will need to have your server's address, and then you'll need to have a secret key and a secret value. And you need to store that inside Databricks such that doesn't get exposed. This is the code on how you can create a secret and how you can store it securely. I have a topic name which I'm trying to read, a target table which I'm trying to write, and checkpoint where like checkpoint is where I'm storing my checkpoint. It's just a location. Okay. So let's go through it. So this is the secrets list command. This actually lists all the secrets which are in a scope. So I have two secrets, Kafka API key and Kafka API secret. I run this command, which gets my username and password into two variables. And now look how simple it is to just start processing data. So here is the code which is going to read data from Kafka. There's only like 3-4 lines here which you need to pay attention. So this is just plain reading call, which is here, which we're giving the servers, Kafka server details. We're giving our username and password. I'm using plain mode. You can use a more secure mode, of course. Then I'm subscribing to that topic, which we created in Confluent Cloud. Uh, our topic is called stock price or something. And then we are saying, go read that topic from the earliest date possible. So whichever is the earliest message which is stored in Kafka, let's get that. This is very important because the default is latest. Sometimes people don't specify it and then they don't have any new data coming into Kafka. And then they realize they're starting the streaming job, but there is no data to read. Specify the starting offset as earliest. And then you are specifying minimum partitions on Spark side. If you're going to read data from Kafka, how many partitions should we have on the Spark side? Usually, you just want to match it to how many ever partitions your Kafka has. So in our case, our Kafka had 6 partitions and 6. One question people ask is, when will I have more than 6, right? Or when will I exceed the number, which is, say, if Kafka has 10, why will I ever go more than 10, right? Only twice in 4 years. And by the way, I deal with like probably 4 use cases a week. So only twice in 4 years did I have to bump this number up to twice the number which Kafka had. That was for latency specific reasons. We had a lot of data in Kafka and we wanted to split whatever data we got from Kafka into two parts such that we can process it in Spark faster. But other than that, just like for beginners, it's so rare. I'm just telling you in case you come across this problem, but just match it to how much ever Kafka has. And then there is another parameter called max offsets per trigger, which is how many messages should I read every time Spark streaming runs. And that number I set to 100, which is quite low because I don't have so much data. You can push this to 100,000. You can really push this to 1 million. Honestly, if you're not testing, I wouldn't even specify this. So it's only for testing. Do I actually specify it? Or another reason I'll specify it is I have a very small cluster and my cluster does not have enough memory. So that's the only reason I'll set this number to lower. But yeah, other than that, that's how you read a Spark stream. And then what you do is there's this display command where you can display any data frame. So data frames can be roughly two types, a streaming data frame or a batch data frame. And you have this amazing display command in Databricks, which you can use to look at the output. When I read the output, there is a key, the value, the topic name, there's the partition number, there's the offset number, there is the timestamp of ingestion. And this, I just did some parsing of the data such that I could see what is in the data. When you're writing a first Spark application, you take this chunk of code and write whatever transformations you want on it, right? And you run the display command. And if you like what you see, you take the next step of writing it into a table. That's all you need to do. So this is a very simple use case. I'm just going to read and I'm just going to write. Maybe I can do some small transformations if I want, or I can do mini transformations if I want. So one question people usually ask is, you're just reading from Kafka and you're writing to a Dell. Why did you even bother? Right? So the answer is Kafka has a default retention policy. Kafka Kinesis, all of these things are expensive. So Kafka has a retention policy attached to it. The retention policy default is 7 days. That is why you want a local copy inside Delta, such that when the retention policy expires, you have the data to go back. You want to do minimum transformations also, because if you wrote some bad code and lost your original data, then there is no way to go back, right? Most of the times I've seen 7 days. Sometimes people do 14 days, 30 days, but that's the max I have seen in my experience. So that is why you want to read and just write such that you get a full copy of your data. And that's why you want to do minimum transformation. You can still do minimum transformation, but keep the original columns intact. You have to make correction. After you have the streaming data frame, all you need to do is a write stream call. This practice I'll tell you is you should give your queries a name. So here, when this streaming query is going to run, you will see I give it a human readable name. It will also get a unique ID, but you will see this name I'm calling write Kafka topic something something, right? And the beauty of it is if you have 200 streaming jobs on a cluster and you hit the structured streaming tab, you will see your, like, imagine if this was like an ID, you wouldn't be able to identify what it meant, right? So here having like a realistic name just help understand on, hey, which stream are we talking about if you have like tons of them. So here what we are trying to say is just take the streaming data frame to this target table. Here is our checkpoint location and try to run this every 2 seconds. So here is processing time 2 seconds. You can change this. You can be like run every 60 seconds. If you're in the second range, it makes sense. You do processing time. And then originally I told you don't have to run your streams all the time. So you can write your code, but not have this pipeline run all the time. And the way you do that is you set this parameter, which is dot trigger available now equal to true. If you do that, the way the stream or your job would work is that it will identify what's there to be processed, and then it will process the data one batch at a time. And after all the data is exhausted, it will shut down the cluster automatically for you. So that's the benefit of trigger available now. Your orchestrator, you say every 4 hours, no change required. If you want to run it once a day, user schedule your job once a day. If you want to run it every 15 minutes, you schedule your job to run every 15 minutes. And look at this. I'm not changing my code. My code is remaining the same. So that's the benefit of Spark streaming. Okay. Now it's more of a deep dive. At this point, you have all of the things to get your first stream going, which is I told you how to store your secrets. I have told you how to set this max offsets per trigger for your testing purposes, or you can set it to a higher number. I have told you how to do a display so you can look at what you have processed. And then I have told you how to write it, right, into a table. This dot to table creates the table and also writes to it. One last best practice I'll tell you is the checkpoint location. Ideally, write a function, like create a class and create a function called get checkpoint location prefix. It's that you give it a table name and you get back the checkpoint location. The reason is you want all your checkpoints to be stored together. That's the reason you should have this. And the checkpoint should, I would say, should be always connected to the target rather than the source, because the checkpoint already has information about the source. That's why I would say create a class and write a function or a method in it and get the checkpoint location such that all your checkpoints for all your streams systematically remain in one place and you don't have to look around where they are. This is for beginners. That's all they need to know to get your first streaming job done. And if you're on Databricks, scheduling is very easy. Change this to available now when you are scheduling your job, because in trigger processing time, it will keep running like forever. So I changed this. Whenever the stream's outstanding data is finished, it will complete on its own. Just click the schedule button, You can say, hey, run every day, every hour. You can give it a machine to run on. Don't set auto scaling on your cluster. Give it a fixed size cluster in streaming. Spark streaming in a dedicated server mode does not have auto scaling. Specify a fixed size cluster when you run your jobs. If I click create, I'll have a job created, and then I can keep changing its cadence. So I can change the cadence to whatever my business needs to be. So right now I'm saying, hey, run this job every hour. You can even change this to be minutes. You can say, run my job every 15 minutes. It will start the cluster, figure out how much data is there to process. And once done, it will kill the cluster. Let me quickly show one more thing for you folks. Now, this is for the advanced audience. So, if you already know Spark streaming, what else do you need to know? So, first things first, your in processing rate should always be near your input rate or greater than the input rate. That just means Spark will be able to keep up with the input. Here you will find this metric called max offsets behind latest. So what Spark Streaming is doing for you is figuring out what's the latest offset in Kafka. So what is the latest message? And it knows where it is. And it does the difference and identifies how far is max offset behind latest. So if max offset behind latest is not increasing, that's what you need to focus on. It will always be behind because there will always be something to process. This number can't be zero if you have active data. But what should keep happening is this number should keep dropping. So as long as max offsets behind latest is dropping for your running streaming job, it means your processing rate is automatically greater than input rate. That's why this is happening. And you are not lagging behind for your scheduled jobs or jobs which are continuously running. That's the metric you should monitor. Now, let me tell you a few more things. So, there are a lot of things here. I won't be able to get into everything. First, there's a sources folder. This is saying, hey, I have a source. It's coming from Kafka. This is the name of my topic. And for partition 2, I am at 1876. For partition 5, I am at 5618. If you remember, I showed you in the PPT that every message has an offset number. So this is what Spark is trying to tell us that, hey, for each partition, I'm at that specific offset. And if you're looking at 1 and 3, they are 0. That just means even the sample data set which Confluent created, they are not publishing data to all the partitions. So here you have a case where the partitions are imbalanced. It's very rare, but in this case, there we have a imbalanced partition. So that's what's there in the start offset. There is also one more thing more, this end offset. So Spark is trying to read data between this start offset and this end offset. This all of this information, by the way, is stored. And then this is the latest offset. So latest offset is means what is the most what is the offset for the latest message. It can do the difference and calculate the max offsets behind latest, right? Hopefully that's making sense. Okay, now again, this is for advanced folks. Beginners, please ignore. So a lot of videos online does not actually tell how Spark streaming works. And it took me a while to learn all of this. But like for me, I can't just believe what anyone says. If Spark streaming says, hey, I can do fault tolerance and recovery, hey, how can you do it? How do you do it? I can't just believe you on face value, right? You won't find a lot of this material online, but here it is. So if you open a checkpoint, we are listing our checkpoint location. You'll find 4 folders inside it, 4 or 5. So find a commits folder, you'll find a metadata folder, you'll find a offsets folder, you'll find a source folder. Okay. So let's look at each of them quickly. I want to really show what's inside this. So inside the sources folder, there's another folder called zero, and zero has another folder called zero. My understanding is that when Spark streaming evolves, maybe it supports more sources. Right now, only supports 1 or 2 sources. You can do stream 2 tables at the same time. So that's my understanding. And what it's saying is inside one of these sources folder, it's saying, hey, I'm reading this topic. which has these partitions 0 to 5. And I started at 0th location for each of them. That's what the sources folder tells us. Nothing interesting. The most interesting folders are offsets and commits folder. So if you open the offsets folder, you will see that every time a micro batch finishes, a file is created inside the offsets folder and the commits folder. Let's sort this and figure out the latest offset. The latest offset is 223. So I'm going to open offset 223 and show you what's inside it. Offset 223 folder was created at this timestamp. Now let's see what's inside the offsets folder. To open a file, I'm using this command called dbutils fs head. This is hard to read. So I created the pretty print JSON function. I'm going to pretty print this offsets folder. And honestly, if you understand offsets folder, commits folder is almost empty. Everything you need to know about the stream is inside the offsets folder. It's using HDFS backed storage. The Spark Shuffle partitions is 200. Most important thing it's storing is anytime a Spark job starts, it identifies what's outstanding. This is saying I'm reading this topic, reading this partition, and inside this partition, I'm going to start reading from offset number 3171. If I kill my job, let me just kill my streaming job. It already actually finished. Available now in practice. Let me show you. The offset folder, remember our offset, we were at offset number 223, right? Now let's look at commits folder. Because the job successfully finished, offset and commits should be in line. So if offset number 223 is there and commit number 223 is there, so it's saying that, hey, whatever I had said I'll do as part of offset 223, I have finished. It's committed. If I remove this folder, it would reprocess the offset. Now, if I start this job once more, it should create offset 224. And if I kill it midway, the 224 commit wouldn't be there. So let me kill it. Now, if my kill happened successfully, now it might also not happen successfully. So you'll see offset 228 and I killed it midway. Hopefully my commits folder 224 did not commit if I didn't kill in time. Clearly I didn't commit in time. The way Spark Streaming identifies what to process is because checkpoints offset folder remembers what is there to process. If offsets folder and commits folder are not in sync, meaning offset number 227 does not match with commit number 227, that means that the job was filled somewhere in between, and when the Spark Streaming job starts again, it will just recover because it knows that it had promised it's going to process an offset, but it did not commit. That's about it. Now let me just show you this metadata folder. There's nothing interesting inside it. Actually, I didn't show you the commit folder first. So sorry, commits folder is very simple. Commits folder does not have much, barely has any information. It has just some watermark information. It just figure out if then commit numbers are in sync. Metadata folder also doesn't have much information. I'll just show you what it looks like. It just has the ID number of the stream, and this ID number is going to match what we see on the streaming UI. Let's see. Oh, sorry, I restarted my stream. So it's somewhere here. This number would match with this one, the stream ID number. So that's what it's going to match with. Okay, so that's about it on the depth of streaming checkpoints folder. I had another thing about state, but I thought it's too much to convey in a single session. So maybe next time we can cover Spark streaming with state. Today, what we covered was Spark streaming without state. Okay, so if you want to keep in touch, you can subscribe to Substack. The link is going to be in the YouTube video description. If you want to talk to each other, I have a Discord server where you can talk to each other. We all are trying to learn, grow in our career, trying to learn or other ways to enhance our skills. And then I also start a new WhatsApp channel where you can keep in touch. If you want to speak to me one on one, you can find me via my website. General questions you can always ask on WhatsApp and Discord. So, what's next? Right? For the next session, I wanted to show you how you can take a regular Spark job and convert it into a streaming job without code changes. When is the next session? It's going to be in the next 2-3 weeks. If you follow me on Substack and Discord, essentially I'll be able to send you a notification. Subscribing on LinkedIn does not really help much because you might not get the notification. Okay, so I hope you folks have a lot of questions. If you have questions on this content, good. If not, you can also ask general questions in the field. The next session, we are going to figure out how to convert a regular Spark job to a streaming job with minimum code changes. When are we going to do it? In the next 2-3 weeks. If you want a notification on, hey, when is this event scheduled, subscribe to Substack and Discord, and then you'll get a notification. Have a good day, folks, and thank you for joining in. If you have any feedback, feel free to message me on LinkedIn or Discord.